Hello, AP Stat students. Today, we are starting a new section in the probability unit, and that section is all about random variables. And we're going to spend the next 4 or 5 days on this topic. It's another way to look at probability. So today is the introduction to random variables. And the definition of a random variable is a variable whose value is a numerical outcome of a random phenomenon. Random variables are used to quantify outcomes of a random occurrence and therefore can take on many values. And they're usually denoted by a capital X, a capital Y, or a capital Z. Okay? So a random variable simply counts the occurrences of certain events. Okay? It can't be used with categorical data, so like it doesn't make sense. Like a random variable would never be like eye color, red, blue, green, brown, etc. But a random variable might be how many people have blue eyes in our class. Or we could count how many people have blue eyes. And maybe in one class it's none, and maybe in another class it's 1, in another class it's 2, etc. So a random variable counts things, okay? A discrete random variable is a random variable with a countable number of outcomes. So that would fit with our how many people have blue eyes in our class. You know, you can't have 3.5 people with blue eyes. So it would either be 3 or 4 or 6 or 10, okay? That's a discrete random variable. So these are whole numbers. A continuous random variable is a random variable where the data can take infinitely many values in an interval. So these are things that will end up being decimals, okay? Like height, weight. Your height is never exactly a value. So you could be like 6.21385976 inches tall, or feet tall. So when you have these really long decimals, that's a continuous random variable, okay? So continuous random variables would literally take forever to count. In fact, you would get to forever and never finish counting them. For example, take age. You can't count age. Why not? Because it would literally take forever. For example, you could be 25 years, 10 months, 2 days, 5 hours, 4 seconds, 4 milliseconds, 8 nanoseconds, 99 picoseconds, and so on. So, that would be a huge decimal. Okay? So continuous random variables, it would take forever to count. So here's some examples. So for discrete random variables, remember you count these with whole numbers. The number of students at Jefferson, because you can't have like half a student. The number of cars in a parking lot, because you can't have half a car. The number of silverware in the drawer in your kitchen, unless you have like half a fork. The number of ice cream cones sold at Baskin-Robbins today. The number of pieces of candy you got for Halloween. So all of those we would count using whole numbers, which makes them discrete random variables. Now, continuous random variables are measured with decimal values. So these are some examples. The heights of women, because you could be half an inch tall, or that could be 5 foot 7.5 inches. The heights of men, same thing. The amount of gas in your gas tank. It's going to be some, crazy decimal in gallons or liters. The length of time it takes you to drive to school, how long it takes to brush your teeth, the weight of your bag of candy on Halloween. Anything where when you measure it, you could get a long, a decimal answer. That's a continuous random variable. So those are the two types of variables we're going to have to be able to deal with. So here's an example of a discrete random variable. So the number of items a given salesman sells per customer is shown below. The table below is called a probability distribution. So when we have a discrete random variable, we'll be able to write out all of the possible outcomes. So apparently this salesman sells anywhere from 0 to 6 items. Okay, and you can't think of it as you can't sell half an item, right? And then there's a probability that goes with each one. So the chance that this salesperson sells 0 items would be 20%. The chance they sell 3 items would be 12%. And the chance they sell 6 would be 3%, apparently. So those probabilities will add to be 1. And in a probability distribution, they will always add to 1. Okay? So then I could ask questions like this. What is the probability the salesman sells 3 items? Well, off the table, the chance you sell 3 is 12%. What is the probability the salesman sells at least 3 items? Well, at least 3 means 3 or more. So that would be the yellow circle in the table. So I have to add all those up. So I would add 12 to 10 to 5 to 3. And that would be 30% chance. So there's a 30% chance that this person sells at least 3 items. Then what's the probability he sells 2 items or less? 2 or less would be this way, in the red circle. And if you add those up, we get 70%. So 20 plus 35 plus 15 is 70%. And notice when I add those two together, 3 or more and 2 or less, I do get that 100% total, okay? So these discrete random variables and the probability distribution are pretty easy to read and pretty easy to understand and know how to answer questions. In our next lesson, we'll learn about how to find the mean of a random variable and how to find the standard deviation. So look for that in the future. Now, for continuous random variables, probably the most famous continuous random variable are normally distributed random variables. Okay, so here's an example of a continuous. It says the heights of young women are normal with a mean of 64 and a standard deviation of 2.7. Remember, that's what this capital N means. It means it's a normal distribution. And then we always get the mean first and the standard deviation second. So I could draw a bell-shaped curve with 64 in the middle, 2.7 is my standard deviation. It says define y as the height of randomly chosen woman. So what is the probability that a randomly chosen woman has a height less than 60 inches tall? So 60 inches is over here. I'm looking for this. So of course the first thing I'll need to do is a z-score. So remember, the z-score is x minus the mean divided by the standard deviation. So it's 60 minus 64 over 2.7, which gives me negative 1.48 as my z-score. Remember, you can round those to 2 decimal places, that's fine. And now to look up that answer, I'm going to do normal CDF. Remember, that's inside distributions. And I'm going to go from negative 10 to negative 1.48. And be sure you're doing the normal CDF, not the PDF command. And I get 0.0694. So basically almost a 7% chance that this woman will have a height that's less than 60 inches. So in a continuous situation, we need something like the normal distribution to find answers because there's no way to make a table for these because your table would be, you'd never be done finished making your table because you keep measuring the height to go closer and smaller decimal. So the only way to do this is to use something like a normal distribution. So this has been an introduction to random variables. Good luck on your homework.